Today we're going to talk about junctions. And very simply, a junction is the intersection in where your wires meet or where your wires intersect. When we talk about junctions, we're talking about current and the amount of current that is flowing into your junction, as well as the amount of current that is flowing out of your junction. When you look at these diagrams, these circuit diagrams here, your junction is represented by this little dot where your intersection is. When we talk about junctions, we have a very simple rule that we have to follow. The total amount of current, where current is our I, going into your junction must be equal to the total amount of current that is flowing out of your junction. No crazy math, no crazy formulas, just the total going in must be equal to the total coming out. So if we look at this first one here, we say, okay, well, we have two things we need to consider. How much is going into your junction and how much is coming out? Well, if I look at my diagram here, I see that I have 5 that is flowing in, and I know it's going in because of the arrow direction. So I have 5 going in, 5 amperes. I then look and say, well, how much is coming out? And according to my diagram here, I have 2 amperes flowing out. We know that these two things must be equal to each other. They have to be equal. So obviously 5 and 2 are not equal. So what do we have to add to the outside to make it equal? 3 amperes, which means that my missing A must be 3 amperes coming out. You indicate it with an arrow. You can write it as out, however you want to do it, as long as you indicate the direction as well as the magnitude of the current you have. For the next one, again, we do everything in the same way. We list what we have going in. We list what we have coming out. When we look here, we look and we say, okay, well, I have 5 amperes coming in. I have 2 amperes coming in. Both of these have arrows that point into your junction. So we know that they're both going in. So we have 5 amperes. We have 2 amperes for a total of 7 amperes going in. Well, on the outside, I don't have anything. And I know that in must be equal to out. So if I have nothing on my outside, I know that I am missing 7 amperes. So this must be 7 amperes flowing out of your junction. For this picture right here, the only difference is now we just have more numbers to work with, but same exact kind of concept. So we have the amount of current going in, the amount of current coming out. If we look at the amount of current going in, the only arrow that we see here that is going in is this one right here, this 1. So I have 1 ampere going into my junction. If I look to see how much current is flowing out of my junction, then I have 1, 2, 3 currents flowing out, where we have 10 amperes, 12 amperes, and 7 amperes all flowing out. This gives us a total of 29 amperes out of our junction. Well, if we have 1 ampere going in and 29 coming out, we know that the missing current must be 28 amperes, such that we have 28 that we can add to our 1 to give us an equal amount of current flowing in and out. So this must be 28 amps, and we know that it must be flowing in to our junction. If we look at the next page right here, we'll do some of these together. Your homework, actually, I put all of these pages together here. And so your homework, actually, I believe, let's see, I clicked the wrong one here, so bear with me. Here we go. Okay, so your homework, I added some extra questions onto here. So your homework is going to come from here, but we can look some of these multiple choice. We can do some of these together. Let's do the first page together. That way we make sure that we're okay with this. Actually, Let's do some of them. Let's just do some of them. All right. So if we look at number 1, we have the diagram shown below represents current flowing in branches of the electric circuit. What is the reading on ammeter A? So obviously we're looking for this current right here. Again, all we need to do is look to see what is going in versus what is going out of your junction. Well, if you look here, you actually have 2 junctions that we need to worry about. So if we look at this first one, the top one, we see that we have 10 amperes that is flowing into this junction. We also have 15 amperes flowing into this junction. That gives us a total of 25 amperes. And what's going to happen to that 25 amperes? Well, that 25 amperes is going to combine, and it's going to travel down its path until it reaches our 8 amperes that is also flowing into that junction. So we have 10 amperes, 15 amperes, and 8 amperes all flowing in to our junction. That gives us a total of 33 amperes flowing into our junction. But I don't have anything coming out, which means that the total that's going to be read on ammeter A must be 33 amperes, such that 33 going in is equal to 33 going out. If we look at number 2, which diagram below correctly shows currents traveling near junction P in an electric circuit? Well, we could do this for all of them. So if we look at choice 1, we have going in versus coming out. We look here and we say, okay, well, I have 3 amperes going in. I have 7 amperes going in. So we have 3 and we have 7. And then I see that I have 4 that is going out. Well, 3 and 7 gives us a total of 10 going in, which is not equal to 4. So I know choice 1 cannot be correct. If I look at choice 2, again, we say what is going in versus what is going out. I look and I say, okay, well, I have 4 amperes going in, 3 amperes going in, and 7 amperes going in. I see it totally based on the direction of the arrows. This means that we have 14 amperes going in, but I don't have anything coming out, and we know that they must be equal, so 2 is not correct. If we look at choice 3, in versus out, we have 4 amperes going in, 7 amperes going in, so we have 4 amperes and 7 amperes going in to give us a total of 11 amperes going in. And I look and I say, okay, well, I only have 3 amperes coming out. Well, 3 and 11 do not equal each other, so 3 is not correct. Let's just make sure we did all of our math, right? And if we did, then that means that choice 4 must be the answer, since that's the only one that's left. If we look here, we have 4 amperes going out. We have 3 amperes going out. So that means we have 4 amperes, 3 amperes to give us a total of 7 amperes going out. We must have 7 amperes going in, and we do, such that 7 and 7 are equal. Choice 4 should be our answer. If we look at number 3, the same kind of question for number 1, choice 1, we have the total amount going in versus the total amount coming out. The total amount going into our junction, we have 2 going in, 2 amperes, and then I have 5 and 3 amperes coming out. Well, that means I have a total of 8 amperes going out, 2 going in. They're not equal to each other. If we look at choice 2, in versus out, we have 2 amperes going in, 3 amperes going in, to give us a total of 5 amperes going in. And it looks like we have 5 amperes that are coming out. Well, this one looks pretty good. Let's just make sure the other ones don't work. So we have in versus out. We have 2 amperes going in, 5 amperes going in, 3 amperes going in. So we have 2, 5, and 3 amperes all going in to give us a total of 10 amperes in, 0 out. Wrong. Lastly, we have 2 amperes going in for choice 4, 5 amperes going in, 2 amperes, 5 amperes. That's a total of 7 amperes. And we only have 3 amperes coming out. Obviously, choice 4 is incorrect. Choice 2 should have been our answer. As you go through and you're looking at these other questions here, number 4 is the same exact question as what we just did. So why redo the math? It is exactly the same. It was just put there twice. However, from 5 and forward, you should be able to go through and get that correct. The only one that I do want to just look at with you, if we look at number 11, in the circuits represented, the symbol for an ammeter is a circle with an A, and the symbol for a voltmeter is a circle with a V, just like what we've been working with. Which diagram represents the proper connections for determining the resistance of a circuit? Well, we need to know which ones are represented correctly. If we're talking about an ammeter, you know that should be inside of your circuit. And if we're talking about a voltmeter, we know that should be outside of our circuit. So automatically, as I'm looking through here, first I see choice 4, and I see that an ammeter is placed on the outside of my circuit, added to my circuit, and I know that makes no sense. I look again at choice 3, and I see an ammeter again is placed on the outside of my circuit. Wrong. If I look at choice 2, I see that a voltmeter is placed on the same wire as my battery. Well, that can't happen either. So if we look at choice 1, I have my ammeter that is on the same line as my battery, my voltmeter that's placed outside of my circuit. Choice 1 has to be my answer.